In the AP Stat curriculum, you're going to be asked to find a least squares regression line 3 ways. Now, one way would be to give you data. So you'd go to list 1 and list 2 on your calculator, and you'd find the least squares regression line that way. But honestly, on an AP exam, you're really not going to be asked to do that. But practically, we should know how to use the calculator. Another very common thing is that you're going to be given a computer printout. You can expect this on an AP exam, which is why as we go through this course, we'll have to get comfortable with computer printouts and reading them and getting the information we need from them. The last way to get a least squares regression line is for us to be given key statistics and then use those to be able to put together a least squares regression line. And that's the problem we want to discuss on this video. That is our least squares regression line. Those are the two formulas that will be provided for you to find the slope and the y-intercept. Keep in mind what you're going to need is the standard deviations of both the x's and the y's, and that should make sense. Slope is change in y over change in x. Standard deviation, variance of y over variance of x. And then we're going to need the averages of the two variables, and we're going to need the correlation coefficient. Now basically, look at that, it's just a thing of beauty right there. Okay, so here's the deal. What we have is these two formulas. A very important idea is that the point x bar, y bar, that ordered pair is on every least squares regression line. So if we look at this just from the standpoint of the x's, the mean average x is right here, and if we have the standard deviation, if we go over about 2 standard deviations, then we should find about 95% of the data points in that interval. Likewise, if we take the average y and 2 of its standard deviations, we should find 95% of the data within that interval. That point is on every least squares regression line. That's how we build it. Comes into play with this formula right here. That forces it to become part of the line. So basically, if we fill this in, here's what's going to happen. So many of your data points, 68%, will be within this interval and this interval. So you're going to see a whole lot of data points in here, in this interval. Right? But as we go out, we get fewer and fewer data points. If we have a negative slope, it's going to come this way. If we have a positive slope, they're going up here. So we're going to see just a few more points down in here and a few more up in here. But a lot of the data is going to be in the middle. So it's going to tend to form an ellipse in here within this rectangle as we're going to find most of the data points. Okay, so we have this right here. We got the general notion that that this is the way things work. So let me actually jump over here. Let's do a particular problem with no context. I'm just going to give you the statistics. Let's say the average of the y's, the average of the x's is 20, and there's your standard deviation of 2. The average y is 30, standard deviation of 3. So do you agree in this case that if we added 2 standard deviations, this would take us to 24, and this would take us to 16. So 95% of the data points should be in that interval. And this data goes from 2 standard deviations below, which is down to 24, up to 2 above, which is 36. So the data should be in there. But really, all we're going to have to do is say, look, there's our 2 formulas. Here's our information. Let's plug in what we know. So let me go grab the orange, and here's what we got. We're going to put the r here, so our slope, b sub 1, is going to be this correlation coefficient of 0.8 times the standard deviation of the y's, which is 3, divided by the standard deviation of the x's, which is 2. So it's going to be 3 divided by 2. That's 1.5 times 0.8, so that's going to be 1.2 is what we're going to get for the slope of our regression line. And then we go to this formula. And the y-intercept is going to be the average y, which is the 30, minus the slope we just calculated times the average x. So it's going to be the average y of 30 minus the slope of 1.2 times the average x of 20. 1.2 times this is going to be 24. 30 minus 24 is 6. So our y-intercept is 6. So our regression line, let's use a different color, red. Our regression line then is going to be y hat, the prediction line is the y-intercept of 6 plus the slope of 1.2 times x. So there it is, there's our line. It starts down here at 6, and it is, you guys, it's going to cut through this rectangle, and I missed it, but it's going to hit the corner here and the corner here, and clearly you can see the point x bar, y bar is clearly on that regression line. Boom, there it is, beautiful, okay? Now, what is going to oftentimes happen is we're going to be given a word problem. So, would you please take a moment and read that word problem, and then we're going to decipher it. Now, we need to use good reading skills and good strategy for solving these problems. Really, where you should start is, what are they asking me to find? You're asked to find the least squares regression line. And remember, there's three ways to do this. Either you're given the data points in two lists, put it in a calculator, crank out a least squares regression line. That, we don't have the data, so it's not that approach. Or you're given a computer printout. That ain't the approach. Or, looky here, you're given a paragraph, and in that paragraph, you can find the different things you need. The x bar, the y bar, the standard deviation of both, and the correlation coefficient. So now, here's something that's really important. A chemist wishes to predict whatever thing you're trying to predict, that is the y variable. After all, don't we call this the predicted y? So that tells you, that gives the problem away as to what the y variable is. It's the pain level of the patient. So there it is. That's going to be the y. That means that the drug dosage is going to be the x. So we'll use a different color for that. The dosage of the drug, that's going to be the x variable. So if we say that the mean dosage of the drug is 45, this then is x bar. With the standard deviation of 5, this is the standard deviation of the x's. The pain, those are the y's. So the pain level, its mean is 5.6, so that is y bar. And the standard deviation is 1.2, that's the standard deviation of the pain level, so that's the standard deviation of y. And I think we're pretty good at saying, well, by golly, that then must be the r value, the correlation coefficient. So we got everything we need. So let's do this. Let's shrink that down. Let's look at our two formulas. And hopefully you understand the first thing you're going to have to find is the slope, because it shows up in this formula. So that's where we start. So let's write down what we know. We know that the r value is the negative 0.66. We know that the mean of the x's was up here. That was the dosage of the drug. That's the mean of the x's. That's 45 milligrams. And the standard deviation for the drug dosage was 5, so that's the standard deviation of x. Then we say, okay, the average of the y, the average pain level was 5.6, the mean was 5.6, and the standard deviation is 1.2. There we go. That's what we got. The rest should be pretty easy. So up here, we put the standard deviation of the y as 1.2. Divide that by the standard deviation of the x, which is 5. And multiply that by the r value, which is the negative 0.66. And what we'll get is the slope of this regression line. And it turns out this slope, got it written down over here, I'm not going to pretend to do that all in my head, but it's going to be negative 0.1584. So there it is. We have the first component of the regression line. So far, y hat is b sub 0 plus b sub 1x. We know the slope. Let's go find the y-intercept. So this is it. We say, well, we take the average of the y's, which is the 5.6. Subtract from that. So subtract from that. Oh, let's use black to do that. So subtract from that the slope, which is right here. And be careful, because that is a negative slope, so it's minus the negative slope of 0.1584. And we're going to multiply that by the average of the x's, which is 45. And we might explain this formula a little bit more later, but just follow it. It's a recipe, and what you get when you do the work on that is you get that the y-intercept is 12.728. So there it is. We have both the statistics that go into this least squares regression line. So the line is the y-intercept of 12.728. Let's go ahead and round that off to 12.73. I'm sorry, I was going to put plus, but it's not plus. The pain level is going down as the dosage increases. So it's a negative slope, a negative 0.158. Let's call it 0.58 is good enough, x. And then remember, we can interpret the slope in the context of the problem. So this is the change in the pain level over the dosage. So for every 1 milligram increase in the dosage of the medicine, the pain level to the patient is going down by 0.158. And it might simply be a case where you ask the patient on a scale of 1 to 10, how bad's your pain? And so we kind of go with it that way. So that's how we use the formula to get the line. So if we think about that then, how does this look on the graph? Well, our average dosage was 45. Our average pain level was 5.6 with the standard deviations that we had. The line of best fit that we just got has a y-intercept of 12. It comes down to the slope of negative 0.158. And that line will hit pretty much the corners of those intervals, 2 standard deviations over in each direction, and sure enough, the point that is on this least squares regression line is where the mean of 45 meets the pain level of 5.6. That point, for a dose of 45 milligrams leads to a pain level of 5.6. That's on the least squares regression line, and that's it. So there's an indication of how we can use those formulas to find the least squares regression line.